Today I will demonstrate on variable selection and model building using R. In series of videos, we have discussed the consequences of the approaches, that is when we include some irrelevant variable or exclude some relevant variables. And then we have discussed several criteria like R square, adjusted R square, malus CP, AIC, partial statistics for variable selection. Then we discussed stepwise regression method. R comes with several built-in datasets which are generally used as demo data for playing with R functions. Here we consider empty cards datasets. The data was extracted from the 1974 Motor Trend US magazine and comprises fuel consumption and 10 aspects of automobile design and preference of 32 automobiles 1973 to 74 models. Here first variable is response variable, remaining 11 variables are explanatory variables, and we consider only 32 observations. Here we consider, in this particular lecture, we consider first three explanatory variables, that is CYL, DISP, HP. Then we consider four explanatory variables, that is CYL, DISP, HP and DRAT. First we explore all possible subsets and then use stepwise regression methods, that is forward selection, then backward elimination, and third stepwise regressions. And we observe that in forward selection no explanatory variable can be removed if entered into the model. Similarly, we observe that in backward elimination no elementary variable can be added if removed from the model. Here we use two functions to build-in function. One is OLS underscore step underscore all underscore possible. This is for exploring all possible subsets of regression model. This is in OLSR package. And another function, that is step capital AIC, this is also built-in function. So this is used for stepwise regression. This is in mass package. There are so many functions available. I only use these two functions to explain the efficiency or efficiency and demerits of stepwise regression method. Lastly, I mentioned that none of the methods among forward selection, backward elimination or stepwise regression guarantees best subset model, but it is not possible to explore all possible subsets if number of explanatory variables is large. So we need a shortcut method, and stepwise regression method is one of the remedy in this direction. So first we open new script. Here we consider only three explanatory variables. So explore all possible subsets, we need the package OLSRR. So we need to install this package first, OLSRR. If you install it directly or you use this code install dot packages within first bracket inverted comma olsrr, first bracket close, second bracket close. This is the code for installing olsrr package. Now write library within first bracket olsrr, then we feed the model using three explanatory variables. Here we use only three explanatory variables: COLI, CYL, DISP, HP. These are three explanatory variables are used. So we recall LM function and feed multiple regression model using three explanatory variables: SYL, DISP, HP, and use the dataset empty cards, empty cards, first bracket close. Then exploring all possible subset, we need the function OLS underscore STP underscore all underscore possible, first bracket open, model bracket close. So this function in olsrr package now we print k, and if we run this portion, first install olsrr package, then we get this output. So this is the output, and here we see that the 7 possible subsets are this: and excluding one subset that is containing only intercept term. Since we use only 3 explanatory variables, k is a number of explanatory variables, so k equal to 3, which I already mentioned in our previous video. So total number of subset is 2 cube minus 1, so that is equal to 7, excluding the subset which consisting only one intercept term. See that first 3 subsets consisting only one explanatory variable, that is SYL, DISP, HP. Then next 3 subset consisting 2 explanatory variables, and last consisting all 3 explanatory variables. Here we consider R square, adjusted R square, and malloy CP. Now we see that subset consisting only 2 explanatory variables, that is SYL, DISP, this gives base subset, because R square, adjusted R square, and malloy CP the malloc CP is close to number of explanatory variables, that is 3, and adjusted R square on R square are high than other subsets. So this gives base subset consisting explanatory variable SYL DI D I S P, these two explanatory variables. So this is best subset. Now this here we mentioned that this subset obtained or based on three measures: R square, adjusted R square, malloc CP. Now we use stepwise regression method. We use all three methods: forward selection method, backward elimination technique, and then stepwise regression. So for this we need mass package. So first we install mass package using this code, or you can install directly. This is the code. First bracket open, install dot packages within inverted comma M A double S bracket close, second bracket close. So this is the code for installing mass package. Then we call the function step AIC, step capital AIC. Here we use AIC criterion. This function in mass package, so we write step AIC within bracket model, within bracket open, first bracket open, model comma direction. First we consider forward selection method, so direction equal to within inverted comma forward comma. If you do not want to see the path or steps, then we write trace equal to false, capital FALEC bracket close. We stored this in step.model. I forgot to write this thing, so please write it here. Library, write it here. Library within first bracket MA double S bracket close. Then if you run this portion, you get the subset using forward selection method. So for output you write step.model. For print the output step.model. So you see that the base subset consisting all three explanatory variables. If you use forward selection method, all three explanatory variables, if you use forward selection method, in reality this is not base subset, because base subset consisting only two explanatory variables, that is SYL DISP, and here we use on AIC criterion. Now if you want to trace the step, then you write 1 instead of false. If you run this portion, you get the steps. That is, first select one explanatory variable, then select two explanatory variables. If criterion meet, then select three explanatory variables if criterion meet, so on. This is the process of forward selection method. So in the final step we get this result, the base subset. If you use forward selection method, then base subset consists three explanatory variable in reality, which is not optimum. Now if you use backward elimination method, then you write backward, so that is direction equal to within inverted comma backward, and run this portion, and if you trace this path, you see that in backwards elimination method, in step 1, select all explanatory variables, that is SYL, DISP and HP, and corresponding AIC equal to 75.21. Then in next step you see that, and these are the sum of square, residual sum of square AIC corresponding individual explanatory variable, and in step 2 we see that HP is deleted. HP is deleted and corresponding AIC is 74.33, and this give base subset if you use backward elimination method. So this is again, we see that in this is again the base subset originally. So if you use backward selection and using three explanatory variable, in this situation you get best subset. Now if you forward selection method, we see that the base subset SYL, DISP, HP, in reality this is not a base subset. Here we mention this point that in forward selection no explanatory variable can be removed if entered into the model. So HV cannot be removed because HV is entered into the model if you use forward selection method. So here we do not get base subset if you use forward selection method. Now we use stepwise regression method, that is both direction forward and backward. So we write direction equal to within inverted comma both, and we want to trace the path. Now if you run this portion, then we get this output. Then again we see that in step 2 we get base subset, if you use this method, the base subset again in reality is a base subset. This consisting only two explanatory variables, that is SYL and DISP. So here again we get base subset if you use stepwise regression, that is both method using forward and backward simultaneously. Now if you use one explanatory variable more, that is DRAT, and if you run this portion, that means if you explore all possible subset, that is in this case is 15, because we use 4 explanatory variables. This is the output. Then we see that the total number of subset is 15, excluding the subset consisting only intercept term. So that is equal to the power 4 minus 1 equal to 15. Now we see that first 4 cases consisting one explanatory variable, then next cases consisting 2 explanatory variable, then 3, and last all explanatory variables. Now we look at R square, adjusted R square and malloc CP, then we see that the subset consisting 2 explanatory variables SYL, DISP, adjusted R square are high compared to other subsets, and malloc CP, that is very close to number of explanatory variables, that is 4. So base subset is SYL, DISP. So this is the base subset, and this subset gives the best subset model. Now see that the R square is 0.75, 0.74 is a adjusted R square, malloc CP 3.8, which is close to 4. So this gives the base subset. So now we use stepwise regression method. First we use forward selection method. So write direction equal to forward. Then if we run this portion, then we get the base subset consisting all 4 explanatory variables. But in reality this is not true, because we have already seen that base subset consisting only 2 explanatory variables, that is SYL, DISP. So here we see that forward selection method does not give base subset. The same reason behind this, that is the reason in forward selection no explanatory variable can be removed if we enter into the model. Now we write backward direction. Now we use method backward direction and we run this program. Then we get this output, and here we see that if you use backward elimination technique, then we see that SYL deleted in step 2, and base subset consisting only 3 explanatory variable, that is DISP, HP, DRAT. Again, in reality this is not base subset. Here we mention this point that if in backward elimination no explanatory variable can be added if removed from the model. So this is the base subset if you use backward elimination method DISP dart, but in reality this is not true because base subset is SYL DISP in reality. So backward elimination does not give base subset in this situation. Now if we use stepwise regression, that is both direction, forward elimination and forward selection and backward elimination, and if you run this portion, then you get this output, and again we see that the base subset consisting three explanatory variables, that is DISP, HP, DRAT. Again, in reality, this is not a base subset because this is the base subset if you use stepwise regression method, but in this situation, but in reality the best subset is SYL DISP. So from this example we can conclude that none of the methods among forward selection and backward elimination or stepwise regression guarantees the best subset methods, but this is not possible to explore all possible subsets if number of explanatory variables is very large. So we need a shortcut method. So but stepwise regression method somehow gives us a remedy, and instead of using all possible subset, if you use stepwise regression method, then you get a subset which is nearly close to base subset. Hope you enjoy this class. We will coming soon with new topic logistic regression very soon.